Uh, this is lecture 11, and we will be discussing about database design and construction in this session. So let us start. So we will have introduction, then databases and software engineering methodologies, database types, database languages, database entities like schemas, tables, primary keys, foreign keys, indexes, sequences, stored procedures, triggers, etc. Then database design. Here we will learn relationship diagrams, also known as ER diagrams. Normalization, relationship among tables, integrity rules, master and transaction data. Then we will learn database management systems and then object relation databases. Databases are integral part of any software product. Most software products need to create and keep permanent data. This permanent data is created and kept in databases. So, databases are integral part of most software products. We see software products in the form of websites or ERP products or specialized products which we use in our everyday life. So, in all of these cases, the software products have a database where it keeps permanent data. Databases are extremely important for many types of software products. The power of search engines like Google comes from their sophisticated and huge databases. Like in Google you do search. So for search, how Google finds out all those results. So essentially, Google keeps all that information in its database, and when people do searching, the information are searched in the database, and then the results which are found are displayed to the user. Most commercial and enterprise software products like ERPs, software as a service, accounting, etc., depend on their databases for all business transactions and reports. Even social media software products like Facebook, Twitter, etc., have databases as their backbone. So, like for example, Twitter has a user interface where people create their account, and then they find out followers, and they follow people, and then people may also follow them, and then they can send messages to their contacts, and they can manage their contacts, manage their profile, and manage their communication with their contacts, etc. So all of these things require permanent data. Without permanent data, this kind of software product will not work. There are two parts of any database: the database engine and the stored data. So when we talk of database, essentially there are two parts. One is the database engine, and other is when the data is stored in the engine. The database engine itself is a software product. Many software companies build software database engines. Oracle Database Engine is created by Oracle Corporation. MS SQL Server is created by Microsoft Corporation. So there are many software vendors who build these database engines, and people use these engines to store their data. Software companies who build software products use one of the database engines to create and store data, which is used by their software product. There are many types of databases. Most databases fall under the category of either NoSQL databases or relational databases. So, uh, actually, there are many kinds of databases. Some you can say the very early databases used to be of file types, and then we came about the relational databases. Then there are also NoSQL databases. NoSQL databases are essentially a file containing data. The data in these NoSQL databases is kept in a structured format. For example, we can store data in an XML file. So if you have a XML file, then it is a database, and the information kept in this file is very structured in nature. So the structure provides the facility to find out data easily. Otherwise, if data is not kept in a structured way, then it will be difficult to find out that data. So one aspect about databases is that you need to find data. You store the data first, and then you need to find that data to do many kinds of things like creating reports or finding information. Like when you need to search something in Google, you search Google. So Google finds out that information in its database and then presents it to you. So one aspect is uh, the data which should be shown. So if you keep this data in a structured format, then it will be very easy to find out relevant data. Otherwise, it will be very difficult. The advantage of NoSQL databases is that they can be stored alongside other kinds of files. For example, an XML file can be kept on a web server alongside the HTML files. As you know, on a web server, you have the HTML files. Even XML files can also be stored over there. Reading and writing from these XML files is fast as compared to a relational database, as they reside near the files which need data from these files. For web-based software products, use of XML files thus can be used to write client-side scripts and perform user validation. So one use of these NoSQL databases is to store some data in a file and keep it on a web server. And when some user validation is required or some sort of validation is required, it can be done using client-side scripts. These client-side scripts will read data in the XML file and then do the required validation. So this is one use of NoSQL databases. The disadvantages of NoSQL databases is that it is difficult to enforce integrity rules to keep atomic and non-repeating data. When a data file becomes too large, then reading or writing in data files becomes very slow. So one disadvantage of NoSQL databases is that since essentially they are files, so if you are keeping a large amount of data, then the file size will become very large, and then yeah, doing anything with this file will be very slow. Like if you want to write something in that file, then it will be slow operation. Similarly, if you want to read something in this file, so the searching operation will be very slow. So this is one disadvantage. Relational databases are the most often type of databases used with software products. Relational databases are powerful and can grow to contain extremely large size of data. The main idea behind relational databases is that data can be kept in different tables. Later, a relation can be set among all these tables so that it is possible to create data and keep this data in different tables. Whenever required to view or modify data, a search through all the connected tables is possible. The ability to separate data in tables and yet be able to connect all this data through a relation between tables is something which makes relational databases powerful. So, relational databases are mostly used by software products, and the reason for their usage and their popularity is that the data you want to keep in these type of databases is you can keep that data in different places, like in different tables, and at the same time, if you need you need some relevant information, then generally there will be some table joins and through this table giant it is possible to find out relevant information. So and all these operations will be very fast because uh, as compared to data which is kept in a file, the finding and doing anything with the data in a file is a very slow operation. Because just realize, if you have say 5-page Microsoft Word document, then searching in this 5-page document will not be a big problem. Searching for say some word will not be a big problem. But suppose you have a Microsoft Word document which is 2000 pages long. So you can imagine, if you need to find out any data, any information in this file, will be very difficult. It will be very slow and very difficult. So you just compare this scenario with a relation database. So in a relation database, suppose this Microsoft Word, whatever information is kept in this Microsoft Word document, is sent to a relation database. So in the relation database, there will be many tables will be created, say 100 tables, or maybe say 30, 40 tables, or even less. It doesn't matter. You can, means depending on your need, you can design your tables, and then you keep all that information in these tables. Then you will create some relationship between these tables. So later when you need to find out any information, it will be very easy. You can do any search, and the search operation will not take much time, because the data is kept at a very small amounts. Like first of all, it is divided into tables, and then inside each table they will be stored in some columns. So data is divided at the very minute level, at the, you can say, atomic level. So this is the power behind relational databases. Relational databases use structured query language, or SQL, to define database entities as well as do all kinds of data manipulation. The part of language which deals with database entities creation and management is known as data definition language, or DDL. So DDL is used for creation, management, or even deletion or dropping of entities like tables or schemas or indexes or sequences, etc. The part of language which deals with data creation and management is known as data manipulation language, or DML. So DML is used for data, not for entities. It is used for data creation and management. So you can create, you can delete, you can modify data using DML. Both DDL and DML use SQL. So for both these languages, SQL is the standard language. Database entities include database schemas, database tables, sequences, indexes, primary keys, foreign keys, stored procedures, triggers, etc. We will discuss about relational databases, entities, and how they work throughout this chapter. Schema is the top level database entity. Now let us learn about schemas. We will learn about the different parts of, or you can say, entities of a database. So one of them is schema. Generally, you define one schema for all databases and database entities for a software product. For example, you can have a schema ABC Bank DB for a software product for ABC Bank. So you name a schema. When you create, you put a name for this schema so that it can be identified at any time, and it should be very relevant for the work. Like when you create a schema for ABC Bank, so you can name the schema something like ABC Bank DB. If you have one more software product, then you can create another database schema for this product. So, uh, Likewise, if you have many software products, for each product you will be creating one schema inside your database, so that all the data related to that software product can be kept in one place. All the database entities for this software product you can create inside this second schema. This way, all database entities belonging to this software will be separate from the database entities you created for ABC Bank under ABC Bank DB schema. Using DDL, a schema can be created or dropped. So the syntax is the SQL which is used for this creation of this schema is create schema and then schema name. So one schema will be created for you. And now let us see definitely how tables are defined. So here one example is that of table account transaction. So the table name is account transaction, and the columns in this table is transaction number, account name, date, debit, credit, amount, balance. So these are typical type of table used with banks for keeping bank account information. And here is the same table with data. So how the data looks when this table is populated. So you can see some rows of data for data for transaction number, data for account number, data for account name, data for date of transaction, etc. is provided. A database table is an entity which holds data. This data is kept in columns. Each table has many rows of data. Each row of data is known as a record. The above table depicts a database table with many rows or records in many columns. There could be many tables in a database. These tables can be joined so that related data can be created in all the tables which are joined with each other. When a search is performed to view or modify data, then it is possible to find out the exact data looked for, and based on that piece of data, view or modification in existing data can be performed. Using DDL, a table can be created, altered, or dropped. So now let us see how we create a table in the database. So the syntax is create table, then table name, and then you put column names with their data types. So this way you can create a table in the database. Using DML, insert, update, delete, or view operations can be done in a table. Ins- Insert in for example now uh, one example of DML for insert operation. The syntax is insert into table name, and then you provide the column names and what values. So you put values, and then you provide the values with their data types, so that these values will be populated in the columns of that table. And if you want to delete a row or record in a from a table, then the syntax is delete from table name where you provide the condition. Like suppose you have a table for employee salaries. So you want, for some reason, uh, record you wanted to delete. So you can put this delete command, and suppose you want to delete one information for a person, for an employee name. So you can put the where clause where the employee name is equal to something. So it will delete that record. Then update operation takes place. The syntax for update is update table name, and then you put set, and then column name is equal to some value, and then you put where clause. So that that specific record will be updated. So this is how you use update command. Then if you want to view some data, then the command is select from table name where condition. Like suppose you want to search or view information about the employee name. So in the where command, you can put the where employee name is something. To join two tables, a key is created on a column in one of the tables. Another key is created on a column in the other table. So how the tables are joined, let us understand. So we create a key on one of the columns in one table, and then another key on the other table, and then using these two keys the tables are joined. The first key is known as primary key and the second key is known as foreign key. So you create a primary key on one table and you create a foreign key on another table to join these two tables. The primary key ensures that whatever data being created in the column on which the primary key is set is unique, and there is no null values in this column. A primary key can also be set on a combination of more than one column. So the primary key, when you set, you need to ensure that the column on which you want to put this primary key, there should be no null values or duplicate values in this column. Otherwise, your primary key will not work. You can also set a primary key on more than one column, like say two columns. The combination of columns is also possible to put as primary key. To ensure that a good primary key is made for a table, some considerations include the data in the column with primary key should not be changeable. So this is one condition that if some data is already there in a column which is the primary key, this data should not be changed, should cannot be changed, because if this information is changed, then it will the in the other table, the foreign table, uh, the data which is related to this piece of data, it will be difficult to find out. Like the relation will not work with this table with the other table. The data in the column with primary key should be simple. So one condition also is there. It should be the primary key column should be simple. It should not be complex. Like in that case, then searching or any other operation like insert or delete or update will be difficult and will take time or may do something wrong. Fact-less data is better for columns with primary key. Now, this is also one important criteria. Like the primary key column should contain factless data. Like suppose you want to create a primary key on say account number of the account information table. So account number is a factful uh, column because it is keeping information about account numbers, actual account numbers. So it is factful. So suppose in future these account numbers need to be changed, then it will be very difficult. Like all the relation with other tables will be affected. So that is why if you create a factless column, suppose auto-generated numbers, you put in a column. So these auto-generated numbers have no relation with data in other columns, but they using these auto-generated numbers, you will have advantage like many advantages. We will learn later about the advantages. So factless data is better for columns with primary key. Factual data has columns of repeating or change. Auto increment numbers are best way to generate and populate data for columns with primary key. In most databases, sequences are used to create auto incrementing numbers. We will learn about sequences now in one of the sections later. Foreign key is placed on a column in a table so that the data created in this column is dependent on data which is created in the column with primary key in the other table, which is joined with this table. So, for the foreign key, is placed on a column in the other table. So uh, whenever some data is created in this column, will always be dependent on uh, data which is there in the in the other table with primary key. If a piece of data in a column with foreign key is not present in the corresponding column with the primary key in the other table, then the relationship between these two tables will not no longer exist. So if a piece of data in a column with foreign key is not present, like suppose I have this record in the table with the foreign key. Suppose say employee name, a record contains a specific employee name uh, in the table with the foreign key, and this in the table with the primary key, this employee number record, a record containing this employee number does not exist. So that means this entry in the table with the foreign key is a orphan entry. It has no master record in the other table. So the relationship between these two tables will not work because the master information must be there in the table with the primary key. So all data belonging to the column with foreign key must already exist in the column with primary key in the other table. So this is one of the important requirements that any information, any piece of data in the foreign key table must be already present in the master table with the primary key. Now let us see to understand about joins. So here is one example of bad join. So we have this account and account transaction tables, and this join is made by linking this account number with this account name. And we created the two columns account number and account name in the account transaction table. So why this join is bad? Let us understand. We know the power of relational databases come from keeping data separate in different tables, and yet all this data is related to each other through table joins. Good table joins are extremely important as this will facilitate building a large database, and still all these pieces of data will be atomic pure and will be easily available when required to view or do any modification, reading or writing these pieces of data will also be fast, as the database engine will have to work less in doing this work. It is because the primary key will be consisting of a simple number, and doing search, insert, and other database operations will be easy and fast. Bad table joins, on the other hand, will lead to repeated, impure, and slow performing data. One example of bad table join is provided in the above figure. The table join is made between account and account transaction tables using columns, account number, and account name. Account number for any bank account is normally unique and is never null, but it can be changed in cases where the number of bank customers have increased and the previous numbers or the length of the previous numbers used for creating new account numbers no longer fit in the number of digits used in creating an account number. In this case, account number of all existing bank account holders may need to use larger number of digits and thus need to be changed. The column account number has also been included in the primary key. This field will contain many duplicate entries as customer names cannot be unique. So the other column in the primary key is the account the customer names, the account name. So many customers can have similar names. So in that case, the data in this column containing customer names may have duplicate entries. Even though with combination of account number, a primary key data will be unique. Still, the fact that the data in this column will be strings. So data coming in the account customer names column will always be strings. It is a bad idea to make searches and inserts of strings as these operations for strings data types will be slow. So when you are using strings in a primary key, then operations will be slow for both search and any data manipulation like creation or modification or delete. There is also a violation of table join rules as all entries for account number and account name are being duplicated in both these tables. So one important factor is we are copying the account number and account name from the primary key table to the foreign key table. So both these tables have the same data for account number and account name. So it is duplication of data. So this is also a reason that the join between these two tables is bad. On the other hand, let us see a good table join. So what we have done, the account table we have modified and now we have inserted account ID column and then we have account number and account name in this table. The other table, account transaction, we have inserted this account ID column. So we have defined that account ID column will be the primary key for account table, and then the this account ID column in account transaction will be the foreign key. Good table joins are the key to build reliable databases with fast operations. In the above figure, there is a table join between account and account transaction tables. This table join is a good one because of many reasons. The primary key selected for the join is the account ID column of the account table. This field is auto-generated, so data in this column will be simple and follow a fixed pattern. So why this join is a good join? So one thing is the the data in this column is auto generated. So this data in this column in this primary key column will be simple and follow a fixed pattern. This field is factless. Since we are auto-generating this number, so it is factless. There is no possibility of any changes in the data. So since this data is factless, so there is no reason this data will be changed in future. This will be a numeric field. Searches and inserts in this column will be faster. We have defined this ID, account ID column as numeric field. So searches and inserts will be very fast. This is a single column. Searches and insert in this column will be faster. And this is a single column. So on single columns, all database manipulations will be fast when the primary key is only a single column. For composite columns where more than one column is the primary key, then these operations will be slow. No duplication of data in the account transaction table. Only the account ID column will have data which is same as that in the account ID column in the account table. Now we have removed the two columns, account name and account number from account transaction table because based on the foreign key, data will be data will be populated in this account transaction table by referring the master table, the account table, and using this relation with the primary key. So there is no need for keeping the duplicate data of account number and account name in this transaction table. So we have removed those two columns and so we have avoided this duplication of data being done in two tables. Now, let us understand indexes. Indexes are used to do speed search for data in databases. Indexes for databases are same as indexes for books. You can search for a keyword in the book by finding the page number from its index. When an index is put on a column in a table, then a keyword list is generated which gives information about data in other columns. This makes searches inside databases extremely fast. So indexes we create to do speed search in databases. Like you have large tables, and you need to find a piece of data which may be residing in one of the records. So searching when you do search, so the database search will search about this keyword in the entire table. Like it will go from the first record to the last record. So a lot of search will be required. It will be slow operation. So this in when we create index, so this database index is very it works very similarly, like when you create index for a book. Like at the end of a book you will see indexes, and you have keywords defined over there which are used inside the book. So for example, you want to search the word programming, and so in the index you see the word programming because it starts with P. So you go in where the P keywords are mentioned in the index. So just beside this programming word, you will find page numbers. So you can see page number say 16 and 120 and some other place where programming keyword has been used. So you see this and you can directly go to that page number and find out information about this programming is all about. So it is very fast. Otherwise, you do not know where this word programming is used in the book. So in that case, if the index is not there, so you go to page number one and search through page number one and find out if programming is mentioned anywhere. Then you go to search number page number two and find out. And this way you keep searching in the book, and this search will be very slow. You need to search through all the book. So instead of this, if you have an index, then it will be very fast. The same way in the databases, you do searching by you just create an index on a table, and in this index entry will have all the keywords which will be there in the columns for that table, and then which record contains this keyword, so that will be created in the index. So when you want to search table in the database, so the index it will find out which record contains this information, and it will go directly to that record number. So in index makes searching very fast. Indexes take their own memory space. Whenever some new data is created, deleted, or modified in a table which has an index created, then this index will need to be rebuilt. If a table has too many transactions, then for each transaction the index will be rebuilt. This rebuilding of index will consume much of memory of the computer, and transactions may become very slow. So indexes should not be created on tables which have many transactions going on. So there is one drawback about indexes. Indexes are very good for searches, but suppose you have a table where too many operations take place every day. So uh, what happens is there is a delete. Say record number 600 is deleted, and now the index in the index the entries will have to be rebuilt because this 600 record number does not exist. So the index will be rebuilt. So For each all of these operation, whenever something is happening in that table, so index has to be rebuilt again. So this rebuilding of index will require a lot of memory. So if you have an index on a table which has so many transactions going on, then all the time this rebuilding of index will take place, and this will slow the operations which you need to do on the insert or update or delete operation. So this is not a good idea to put indexes on transactions tables, which where you do a lot of transaction in those tables. So indexes should not be used on such tables. Tables which are used for reporting are the best places where indexes are most useful. Reporting will become fast if indexes are put on these tables. These tables are also not transactions or transaction oriented, and so indexes do not consume computer memory much. So indexes you can put on tables which are used for reporting, where there are not many transactions going on. So not many times the index will be rebuilt. So for those tables, it is a good idea to put indexes. Now let us understand sequences. Sequences in databases are used to generate auto increment numbers to be used to populate columns with unique data. Since numbers generated by sequences are factless, unique, and do not contain null values, they are used to populate columns or tables with primary keys. So sequences are used to generate unique, uh, simple numbers, which can be used to populate columns, primary key columns. Stored then, so sequences this is all about sequence. You create sequence, and you use this sequence to generate new numbers for those columns, and it works that way. Like each time there is some new record to be put in a table with a primary key. So the next number will be generated by the sequence and provided to populate this new record in the table. Now there is one more entity in databases which is known as stored procedures. Procedures are pieces of software programs which can be saved in the database. When these programs are run, then they perform database operations and perform required computation. Stored procedures run very fast as they reside near to the database entities. Stored procedures are simply programs which are stored in the software in the database itself. Like we have a software product, and there we are doing some database manipulation. Uh, so in the programming side, in the business logic itself, we have SQL commands, and we are doing manipulation. So whenever the SQL commands are there, so the business logic will connect to the database and then run this SQL command. So from the database, some database operation can happen, and then some data may be fetched or some data may be modified in the database, and then coming back to the business logic. So this in this arrangement, it is a slow process because from the business logic, everything will go to the database, and then from database it will come back. So this takes some time. But if the same thing you put in a stored procedure, all the SQL queries you put in a stored procedure in the database itself. So since this stored procedure is residing in the database, you just uh, recall the name of the stored procedure and it will run. And since it is inside the database, this process will be very fast. So this is the use of stored procedure. So here is one example. We have created a procedure account insert, and we have used the variables. We have defined variables: account ID, which is of integer type, then account number of var character type, and then account name, again var character type, and the length of these are 15 and 6. And then you begin the operation. So we are doing insert into this account table, and then the columns of these tables: account ID, account number, account name, and we put some values. So these values will come from these variables we have defined: account ID, account number, account name. So for when we run this, we provide this values for these variables, and these values will be used to insert or record in this account table. And then by the end comma statement, we end this procedure. So in this stored procedure example, a stored procedure named account insert is created with three variables. In the database table account, an operation is done using the values stored in these variables. Now let us come to triggers. So triggers are very similar to stored procedure as they are software programs which are saved in the database. Triggers are always associated with an event. So the difference between triggers and stored procedure is that triggers have an event associated. So whenever this event happens, then the trigger will fire and it will run. For example, if you have put a trigger whenever some delete happens in a table, some record is deleted. So you can put a trigger which will fire whenever this operation happens. So triggers are used always with some kind of event. When this event occurs, then the trigger gets activated and is executed. For example, if a delete operation is performed on a table and a trigger is defined for this operation, then the trigger will fire and the programming code written in the trigger is executed. Triggers are not used much. Triggers are difficult to control. Triggers can cause corruption in data as controlling them is difficult. So triggers are not used much because they are dangerous. It is difficult to control when means you have not thought about something which can happen, like you put a trigger for delete operation, but with delete operation something also is going on in the database, and this trigger also got fired. So in that case some corruption of data can happen. So control of triggers are means it is totally automated. There is no control at all in your hands. So yeah, generally triggers are not favored. Now let us come to understand how we design databases. So databases are designed using entity relationship diagrams. And what are these entity relationship diagrams, also known as ER diagrams? So suppose you have books which are written by some authors. So there is a link between the authors and the books. So the link is the author writes books. Similarly, a book is sold at a bookstore. So a bookstore has some book. So there is a relationship. So you find out relationship between entities uh, which either create data or consume data, right? So here, suppose a book is written by some author. So the author has written this specified book. So there is a direct relation between these two entities. And then the other so one aspect is the relation between entities, and the other aspect about ER diagrams is uh, what are the attributes of an entity. For example, the book has say ISBN number. Then some book ID is generated for each book for say this book store. Then the book has a title, and the book has some price, and the book has some author name. So these are attributes of this book entity. So you also need to find out the attributes. So this way you will be able to design a database. So for example, for this bookstore, you can create databases like what tables you need to create, what columns you need to create in the store in these tables. So you can have say a book a table for books, and there you can keep column names to store information about ISBN number, book ID number, title, price, author, etc. And then you need to relate this table book with the say table author, and the author may have information like the author name, his email ID, his some other information about the author. So which books are written by which author, so you need to create a join between these two tables. So using this relation, it is possible to do that. Entity relationship diagrams, ER diagrams, are used to design databases. To design a database, the first thing to find out is the entities which will either generate or consume data. Once entities are identified, then you need to find out attributes of those entities. Next, you need to find out the relationship among those entities. These three things are depicted in any ER diagram. So here diagrams are all about entities, their attributes, and their relationship with other attributes. So these three things are depicted in any ER diagram. If you need to create a database for a book store, then the entities can be books, stores, and authors. Each book can have attributes like author name, title, price, subject, etc. Similarly, other entities will have their own attributes. The relationship among entities can be thought out by finding what kind of data they will generate or consume and from whom. For example, a book can be written by one or many authors. At the same time, an author can write many books. This means that the books and authors have a many to many relationship. We can have just one store, but this store can have many books. Here we can see that a one-to-many relationship exists. Now, let us the other aspect about designing databases is normalization. So, data in a database table should always be normalized. So, what is meant by a normalization? Let us understand. Let us see one example here. So, this table is not normalized. Why it is not normalized is because in the debit credit column you see many values. Like here we have similarly in the transaction date there are many values. So for example, customer Gary, there are two transactions on one date. So there are two entries, and there are two debit credit transactions. So two entries. So this is not normalized. And why it is not normalized, better understand. A relational database should contain atomic and unique data so that it becomes useful to a software product. ER diagrams help in finding out entities, their attributes, and relationship among these entities. Using ER diagrams, we can design database tables, and their relationships. The next level of design aspect for databases come when we think about quality of data which will be created and saved inside the database. Normalization is the process of finding out if the data which will be created will be atomic and unique. Any table in a database can be in any of the three normal forms. So, normalization process in the normalization process, we can normalize by going through three phases, and these are we call it normalization forms and or these stages. In the first normal form, and then we can have second normal form and third normal form. So what is the first normal form? If created data is stored in a database table where there is no list of data in any of the columns in the table, then it is in first normal form. All data in the table is the atomic, and thus this table is in first normalization form. So, for example, in this table which we saw, there is duplication of there are more than one entry in each record. So this is not normalized. So how it can be normalized is that we can create say two records for each two records for each of them, like say here it is repeating, means there are more than one entry uh, in one column in one because it is not normalized. What we can do is we can create some either create some column or create two entries, like we can put the time stamp, like say that change the time stamp, like transition date, we are only putting the date, and if we modify this column to include the hour and minutes and seconds also, so that way this table will be normalized, because with the time stamp, exact time stamp, these two transactions will be separate. Okay, so there will be two records for Gary for third of for 15th of March 2014, because the time stamp will be different. So for other places where also this is, there are more than one data in one column, so they can be separated out, and this table will become normal will come in first normal form. If created data is stored in a database table where there is no list of data in any of the columns in the table, then it is already in first normal form. All data in the table is thus atomic, and this table is in sorry, the first normal form we have seen. The second normal form is if created data is in first normal form and all data in columns are dependent on the data in the primary key column, then the table is in second normal form. So, if the data created data is in already in first normal form, and apart from this, all data in columns are dependent on the data in the primary key column, then the table is in second normal form. So one example we saw very early, like back table joint, where the tables account and account transactions uh, were joined using the account number and account name. So even though the table was the join was bad, but still the data will be in second normal form. Then the third normal form, if created data is in second normal form, and if no data in any column is dependent on data in any other column apart from the primary or secondary key column in any table, then this table is in third normal form. So then we also saw a good table join where we created a new column, account ID, in the account table, and we created account ID in the second account transaction table, and we deleted the previously used columns, account number and account name, from this table. So now the all the data is in good shape. There is no duplication, and the primary key is good. It is factless, and it is simple, and it is pure. So this is in third normal form. So in the second normal form, even though means the data is in first normal form, and the primary key column, the all the information in other tables are dependent on the primary key column. So it is in second normal form, and in third normal form, then there is no duplication of data also, and there is no the data in the other columns apart from primary key or foreign key column, they are not dependent on the data in the primary key, so it is in third normal form. In the above figure, a database table with data is depicted which is not normalized. You can observe that in debit credit column, there are many pieces of data in many rows or many records. Now let us see different kind of table joins. So we can see one to many joins, which is very common. Then many to many table joins, that is also common. And then there are some other types of joins like uh, self join and then one to one table joins. So the first diagram here is one to many relation. So we have a store table and books table. So for example, we have one store and it has many books. So that is why it is one to many relation. And this one to many relation is done by joining these two tables on the store ID field. So store ID field in the store table uh, is the primary key, and store ID field in the books table is the uh, foreign key. So this is how you can depict one to many relationship. Then we also discussed that a book can be written by many authors. At the same time, uh, many authors can write a single book. So there is many to many relation between these two entities, author and books. So to depict a many to many relationship, we need to create additional table. So that we can have a one-to-many relationship with this intermediate table, and again many to one relationship of this intermediate table with the other table. So here we have created an intermediate table books details, and we have two columns here, author ID and book ID. And now we join the author table by using the author ID field in this author table with the author ID field in the book details. And similarly, with the books table, the book ID field in the books table is used to join with the book ID column in the book details. So this is many to many relationship. The top figure depicts one to many relationship between a store and books it is selling. The store has attributes like store ID, address, phone, email, etc. The book has attributes like title, ISBN number, book ID, store ID, etc. The two tables are joined on the store ID field. The store table has the store ID as primary key, and the book table has store ID as foreign key. The relationship between books and authors is many to many. To create many to many relationship between two tables, an intermediate table is created. One to many relationship is created between one table and this intermediate table. Another one to many relationship is created between this intermediate table with the other table. For this purpose, an intermediate table book details have been created. Now we can have a many-to-many relationship between books and author table by having one-to-many relationship between books and books details table, and one-to-many relationship between author and books details table. Then let us discuss self join. So in the self join, what happens is you have information in one table, and this information uh, has a set of you can say a subset of data which is joined with the other data in the table. So for example, uh, generally say for example we have a company where there are many employees, and there will be some managers. So the managers are employees themselves. So in this case, there is some information about managers which is common with the employees. So you can do a self run in this table to know which managers uh, which managers are are bosses of which employees, or which employees report to which manager. So this can be done using a self join. Similarly, suppose we have university where there are many professors and they are teaching many students. And now suppose uh, many professors are themselves students. So in this case, you can do a self join on the table to find out uh, which professors uh, have which students and which professors are themselves students. Like for example, uh, there was a table where there was listing of this information about students and professors. So there was a professor Mary, which was a student of Chris. So on some subject, Mary was taking courses from Chris. At the same time, Mary was teaching Chris. Chris is also a student for some subject where Mary is a professor. So this way, uh, the relationship between professor and students can be found out. Now there is one more type of relationship which is known as one-to-one. This is a rare kind of relationship which is used in very rare cases. For example, suppose we have a database where there is information about roles to access the software product, and some of the roles are sensitive, like they are administrators or do some kind of say some kind of work which is very secret or which is confidential in nature. So you can define a sensitive roles, and then we have the general roles for this database. So this sensitive role is has a one-to-one relationship with the normal roles. So these two tables will have a one-to-one relationship. So we have been talking about table joins and the primary key and foreign key. So these table joins are governed by integrity rules. So let us understand what are these rules. We have seen how to create a join among databases, but database tables using primary and foreign keys. These keys are governed by integrity rules. The primary key is governed by entity integrity rule, and the foreign key is governed by referential integrity rules. The entity integrity rule states that a primary key column should not contain any null values. So the entity integrity rule says that the primary key column should not have null values. If it does, then a relationship with a foreign key column cannot be maintained. So if there is any null value, then the relationship will not work. The row or record in which a primary key column contains a null value cannot be uniquely defined. So this is the reason why the relationship will not work. The referential integrity rule states that data in the foreign key column must match with data in the primary key column. So the other rule is referential integrity rule, and which governs the foreign key. So it states that the data in the foreign key column must match with data in the primary key column. So if there is some piece of data in a foreign key column which is not there in the primary key column, then the relationship between these two tables will not work. If any data in the foreign key column does not match with data in the primary key column, then the relationship between these two tables is not valid. So, and how those rules are governed, so you can impose them using these impose them. Actually they are built in, like when you create a primary key, so the rule is built in this key when you create. Similarly, the referential integrity rule is imposed when you create a foreign key on a column. Now let us move to think about type of data which is populated in tables. So essentially, you can categorize all the data which is populated in tables as master data and transaction data. Master data is about entities and their attributes. In contrast, transaction data is about transaction transactions which happen on a daily basis. So master data is about, it tells you about attributes or the entity name or its attributes. Like say you have this uh, account table. So in the account table you have account number and account name. So it tells you about the name of the people who have the account and their account numbers. So this is a master table, it master data you can say. In contrast, the account transaction table is contains transaction data, because it contains data about transactions like any debit or credit is happening in the accounts of these account holders. So there will be a lot of data entry for all those transactions. Once master data is defined, then it seldom changes. So generally, one aspect about master data is it does not change. Like when you create the account numbers and account names for the account table, so this information does not change once it is defined. It very rarely likes if a person changes its name, then this account name may get changed. Quantity of data used for populating entities and their attributes is small, and it may increase only when new entities or their attributes need to be incorporated in existing tables. So the amount of data which you create for these uh, master tables, you can say, is not much. Like in the account table, you have entries only for account name and account number of the people, and this does not change. Only there will be, say, some new person opens an account with the bank, so a new record will be created for this person. So generally, quantity of data is not much for these master tables. Transaction data, on the other hand, keeps increasing on daily basis. Volume of data thus always tend to be very large. For example, a software product for payroll will have transaction data about salaries and other payments given to employees over time. Each week or month when salaries are given, there will be large amount of data added in the database about these given salaries and other payments to employees. When designing database tables, aspects about master and transaction data must be taken care of. Otherwise, redundant data may enter into database. For example, if master data creeps into transaction data, then all these master data will be duplicated entries, as they will also be there in the master tables as well. So you need to be careful about designing the tables. Like in the transaction table, the data is huge. Every time some transaction happens, there will be a record created. So generally, the transaction tables have large amount of data, and if by mistake you design this transaction table where some master data will also be there in some column, so they will keep repeating and will consume a lot of memory space, and unnecessarily it will be waste of resources. So they should be avoided. All master data should always be contained inside master tables. Master data should be linked to transaction data through table joins. Now let us discuss something about database management systems. Database management systems are specialized software products which rely heavily on databases. Some examples of DBMS systems, which they are also known as, include payroll management systems, electronic data processing or EDP systems, financial account systems, manufacturing and warehouse accounting system, etc. So DBMS systems are specialized software products which rely on data heavily, and some of these examples are mentioned here. These systems are characterized by using user interfaces which are meant to do some transaction and save the data created during these transactions. So, the DBMS system generally have user interfaces where the user will do some input, and this input will result in creating records in the databases. Generally, there will not be any interfaces in such systems where some where no database operation will take place. Generally, all the interfaces in such systems will have some kind of data input, and this data input will result in some kind of database operation. A lot of transaction data is created by these systems. They are also reporting user interfaces which are used by managers to get various reports. Since pure data is important for these systems, databases need to be very secure. So, for these systems, the database is very important, and they people who design such system, they ensure the kind of database engine they use and the kind of database design they do uh, should be done very carefully. Now let us understand something about object relational databases. When we were discussing objects and programming, we talked about the class and design class diagrams and object diagrams, and we also mentioned there that software product may have user interfaces and business logic and database. So the business logic is designed to take care of all the business logic which you need to write. And then when it comes to database again, using ER diagrams, you design the databases. So you are essentially doing replicating the work at two places. If you can design a system where you are using object-oriented programming, where you have objects and the structures the objects provide. So it is possible to use the object structures very same as database structures. So in that way, you do not need to do design at two times. So one design will work. Like if you design the objects structure, then the same structure can be used for creating your database. So that is the idea of relation databases. For example, here you have a user role and you're creating a class for this user role. So you have a attributes like role ID, name, and description. Similarly, when you save information or do any modification data related to a user role, so you have a database which has can have a table with the columns like role ID, name, description. So you are when you come to the database, you design this table, and before that, when you were to write the business logic, you created object structures for keeping this information. So it is possible to merge these two, and you have just one design which will fit both needs. So that is what is known as object relational database. So some companies like Microsoft and Oracle are working on this technology so that This redundant work in designing at two places can be avoided. So this was all about databases, design and construction. So thank you for your time. In the next lecture, we will discuss software testing. So let us see you in the next session. Thanks for your time. Bye.